So this is the page 596, problem 16. We have A equal to 2, and B equal to 9, and C equal to 5. So right now, A plus C is equal to 2 plus 5 is equal to 7, and 7 is less than 9, which is the length of B. So just no triangle, right? So the number of the triangle is 0. Now let's look at the problem 18. 18, we have A equal to 3, and B equal to 15, and C equal to 16. Okay, let me copy this notes on the whiteboard. So A is equal to 3, and B is equal to 15, and C is equal to 16. So, and you can check all these three sides satisfy the triangle inequalities. Okay, the sum of any two sides is bigger than the length of the third side. So now, after we know they can form a triangle, then let's get the order of the three sides. So we have the A less than B and B less than C. So C is the largest side. So we begin with the largest side and find the angle opposite this largest side. And this angle is also the largest angle in this triangle. So we try to find the cosine gamma. Gamma is opposite the side C. So by the formula we just got in the one of the previous problem, we know this cosine gamma is equal to A squared plus B squared minus C squared over 2AB. And we solve the one of the formula in the law of cosines to get this formula for the cosine gamma. Now, let's plug in all those numbers into this expression. 3 squared plus 15 squared minus 16 squared, and then divided by 2 times 3 times 15, and this is equal to negative 11 over 45. Then gamma is equal to arc cosine of negative 11/45, and which is approximately equal to 104.1 degrees. Then we know the other two angles must be the acute angle, right? So now let's try to find the beta. We use the law of the sines to find the beta. So sine beta, which is equal to B times sine gamma over C. Okay, we got this formula before. And then we plug in all these knowns. 15 times sine 104.1 degrees over C, which is equal to 16. And this is approximately equal to 0.9093. And then beta is equal to arc sine of this 0.9093. Okay, this angle beta is equal to approximately 65.4 degrees. And then lastly, you find the angle alpha, which is equal to 180 degrees minus beta minus gamma. So you plug in the angles beta and gamma. Then finally, you get the angle alpha, which is equal to 10.5 degrees. Now let's look at one more problem on the page 596. Let's look at the problem 20. Now, in this problem, we know the two angles and one side. Then we need to find the number of the triangles. Tell me, what is the number of triangles? Is there any triangle possible in this case? Yes or no? And let's go to the whiteboard. So let me copy this problem here. So problem 20, we know the length B equal to 6. Alpha is equal to 62 degrees. And gamma is equal to 120 degrees. So you know the sum of the three angles of a triangle is equal to 180 degrees, right? But right now, alpha plus gamma, just these two angles unknown, is equal to 182 degrees, which is greater than 180 degrees. Where can you find the position for the beta, right? So this is impossible. So just no triangle. Okay, now let's look at the problem 6 on the page 596. So this is one example of the case, two sides and one included angle. And let's copy this problem on the whiteboard. So we know the A is equal to 1.3 and B is equal to 14.9 and gamma is equal to 9.8 degrees. So let's first draw the sketch of this triangle. So right now we know the A, and we know the B, and we know this gamma. Then we need to find the C, beta, and alpha. So first, let's find the C. Okay, so by using the one formula in the law of the cosines, C is equal to the square root of A squared plus B squared minus 2AB times cosine gamma, because we know the angle opposite this length C. So we know C squared is equal to A squared plus B squared minus 2AB times cosine gamma. Now you plug in the knowns into this expression. You have the square root of the 1.3 square plus 14.9 square and minus 2 times 1.3 times 14.9 and times cosine 9.8 degrees. And this is approximately equal to 13.6.